Alright, this is the solutions video for the test fall 2012 over chapters 1 through 3. I'm going to go through these quickly, hopefully. Number one is sample population and is it representative? So the sample is of 3 customers that actually came and got asked the question and submitted an answer. The population that they're trying to infer to are all the customers, and we would say this is not representative because this is a convenience sample and obviously it's really a small sample too. And number 2, which ones are not changed by adding a constant? So if I add like the same, like 5 to everything, the mean will go up 5, the median will go up 5, but the spread stays the same. So anything that measures spread will stay the same, which is the standard deviation range and IQR. 3, it's an observational study because they did not control any variables. They didn't have a control group or an experimental group. So if we just watch to see what happens, that's called observational study. So that's what number 3 is. They're not manipulating a variable. Number 4, we don't want to harm people, so we should do an observational study instead of an experiment, which would force us to subject certain people to harm. Number 5 is just random. 6, a few people had problems with that. That's stratified. So if I break it up into a category, we stratify. And number 7 is systematic because it's every 9th person. 8, list all the numbers, and then what's the median, and that's 7.89. You just count to the middle. Number 9, make your histogram, and so it looks like this, and that would be described as unimodal and slightly skewed to the right because it definitely has a mound here on the left, and then it kind of tails off. And which is higher? The mean would be higher. The mean gets pulled with the skewness. So if the skewed to the right, the mean will get pulled to the right, which will make the mean higher than the median. On 10, a lot of people made a mistake here. There was an odd number, so if we look at 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So the middle number is 74, which if we count to the middle, there would be, we'd use 74 the top half and the bottom half. So some people said, oh, now we forget 74 and say, oh, the middle of the bottom half is 64. That's not correct. 74 is in the bottom half and in the top half. So the first quartile is going to be the middle of the bottom half, which is halfway between 64 and 68, which is 66. And the top half is halfway between 81 and 92, which is 86.5. So if you messed that up, I just took 2 points off. But if you did all the other calculations right based off those wrong numbers, it was okay. So there's the mean. The fence is 1.5 IQRs, so that's 86.5 plus that, which makes 117.25. And the lower fence is 1.5 IQRs subtracted from the first quartile. And there's the box and whisker plot. A lot of people forgot to put a scaled line there to know where these would be, and the box and whisker plot needs to be off that line. So that was just kind of the biggest error, was not realizing to use the median in both the top and bottom halves. Number 11, make a box and whisker plot, so just 1, 2, 3, and 4 with the decimal points, and then here's all the decimal parts. And then this would be unimodal because this is kind of the major mound, and it looks like it's skewed left. If you turn that sideways, it would be skewed to the low side a little bit. And the median is 3.6 if you count to the middle. On 12, 1 standard deviation below, so you got to show the sketch for a point, get the z-score, which is -1 for a point, and then look it up in your z-table, which is 0.1587 or 15.87%. I also accepted 16% if you use the empirical rule. What percent are above 3.9? Again, drawing is worth a point. Z-score is 2 standard deviations, and we want area to the right, so we take 1 minus that probability, which gives us about 2.28%. And the third one is the area between, again, shade between. And pretty much you just take what's the area below 3.9, which is 97%, the area below 2.1, which is about 16%. The difference is the area between, which is about 81.85%. On 13, we find the z-score again, make the sketch, 1.22, look that up in your z-table, and there it is, about 88%. On the second part here, we want the area to the right, so we take 1 minus that, which gives us about 11%. And then the third part, area between, well, we know that there's 88% below, what percent's below the middle is 50%. So you just take 50% away from the 88% and you get about 38, 39% there. On number 14 here, we're supposed to determine which score is better, an 82 on an average of 70 with a standard deviation of 8, or an 87 on an average of 75 with a standard deviation of 14. So we just find the z-scores here, and the z-score on the first test is 1.5 standard deviations above normal, and the second one's a little under 1, 6/7 of a standard deviation. So the first score, the 82, is actually better in comparison to the other scores. On 15, we're supposed to find the standard deviation by hand. The average is 6, so we find the difference each data point is from 6, so like 3 minus 6. Then we square it, and we do that for each data point and divide by n minus 1, and there's 5 pieces of data, which would be 5 minus 1 is 4. So here's all those differences squared, which gives us 26, 26/4, which is 6.5. We take the square root of that, so our standard deviation is 2.55. So hope this video was helpful, and if there's any questions on that, make sure you check out the solutions online that are written out, and obviously you can rewatch any parts.